Good morning, sir.
Yes, good morning, students. So now we will move to the Schrodinger time independent and time dependent wave equation. First, we will solve for the time independent wave equation. We will solve Schrodinger time independent wave equation. So this Schrodinger equation is the most important equation in the quantum mechanics, which gives the behavior of the wave. So what is its position, what is its energy, what is its potential. So all this information will give by this Schrodinger wave equation. So it is time independent, means it is the independent of the time that equations we are going to solve. So we will consider a system of stationary wave. We will take stationary wave. So if a wave is there, means according to the de Broglie hypothesis, so it has a particle. So stationary wave associated compulsory with particle. So we will consider let x comma y comma z be the coordinates of the particle, and psi be the displacement. We will take displacement of the particle. So the differential equation can be written as the differential equation can be written as dou square psi by dou t square is equal to v square dou square by dou x square, dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square. So the differential equation. So now what we have did, we have considered a system of stationary waves, right? So stationary waves which is associated with a particle and which is able to move at x and y and z direction. So this particle, the new function you got as a psi. So this is a displacement of the particle, that is function of time, that is psi function. You have got the new thing in here. So this equation can be written as dou square psi by dou t square is equal to v square. We can write del square psi, we can write, because we know that del square is equal to dou square psi by dou square by dou x square plus dou square by dou y square plus dou square by dou z square. We know that, so we can replace this thing by the del square, right? So we'll make it equation number 1. Alright, so now if you solve this equation, so we will get psi is equal to psi naught sine omega t. To solve this equation, we will get psi equals to psi naught omega sine omega t. So now what we are doing is we are differentiating twice this equation. Equation 2 we get, so if you differentiate this equation, what we'll get, dou psi by dou t is equal to psi naught, sine differentiation is cos omega t into omega will get. Again, dou psi by dou t is equals to psi naught omega cos omega t, right? So again I am differentiating dou square psi by dou t square is equals to psi naught omega minus sin omega t into omega, right? So what we can write? Sin naught omega square minus sin omega t, which is equals to minus omega square sin naught sin omega t, right? So for omega naught we can write 2 pi nu, right? We can write 2 pi nu, and psi naught sin omega t can be replaced with the psi, so we can write psi, right? So this will become minus 4 pi square nu square psi, which is dou square psi by dou t square, dou square psi by dou t square. If you substitute what it dou square psi by dou t square, now what we'll do, we will substitute this dou square psi by dou t square value in equation 1. Here we are having dou square psi by dou t square, it's also v square del square psi. So that equation will make it as an equation number 2. Equation number 3. Substituting equation number 3 in equation number 1. So we need to substitute the equation number 3 in equation number 1, that is minus 4 pi square nu square psi equals to v square del square psi. As we know, the frequency nu is equals to c by lambda. So this will be applicable to the non-relativistic particle whose velocity must be equals to v. So we can replace nu with the v upon lambda, that is minus 4 pi square v square by lambda square psi, which is equals to v square del square psi. So this v square will get cancelled. So this equation will become del square psi. This minus 4 pi square will send here, plus 4 pi square by lambda square psi, which is equals to 0. Now we'll come to about the energy of this system. The energy of the system is E, and potential energy is V. Then so we know that the total energy is equals to sum of potential energy plus kinetic energy. So as we know that E equals to sum of potential energy plus kinetic energy, so that this means that kinetic energy is equals to total energy minus potential energy. So kinetic energy, we know that half mv square, which is equals to E minus potential energy is given by V. We can write as in V. So half mv square, so multiply m on both sides to become, so we want the value of m square v square. So m square v square equals to m E minus V. So we can write m square v square equals to 2m square 2m E minus V. So we'll go to our equation del square psi plus 4 pi square by lambda square psi. Here we will recall with the de Broglie hypothesis. This is lambda equals to h upon mv. So lambda square we will replace with h upon mv. So this will become, so this equation will become del square psi plus 4 pi square by h square m square v square psi, which is equals to 0. So now this m square v square value already we got. This value will keep it here. So that is del square psi plus 4 pi square h square. This m square v square equals, so we can write 2m e minus v psi is equals to 0. So one more point, we know that h cross is the limiting value of h, that is h cross is equals to h by 2 pi. So this h we will replace with the h cross. This implies that h equals to 2 pi h cross we can replace. So we will replace this one. This implies that del square psi plus 4 pi square. So 2 means 4 pi square h cross square 2m e minus v psi equals to 0. So this 4 will get cancelled, pi square will get cancelled. So we'll get del square psi plus 2m h cross square by e minus v psi is equals to 0. So this is the Schrodinger time independent wave equation. Shall I rub? Independent wave equation. We'll move to the Schrodinger time dependent wave equation. That is the second point of us. Schrodinger time dependent wave equation. So just now we had the Schrodinger time independent wave equation. To solve this time dependent wave equation, there are so many methods we can able to solve this equation. But by using time independent wave equation, we are going to solve the time dependent wave equation. So to solve Schrodinger time dependent wave equation, we are using Schrodinger time independent wave equation. So from the time dependent wave equation, we are having dou square psi by dou t square is equal to v square del square psi. This will make it equation number 1. This is the time independent wave equation has been given by the beginning of the Schrodinger equation. So the complex conjugate of equation 1 is, we can write psi is equal to psi naught e upon minus I omega t. So omega is angular velocity that can be replaced with the 2 pi nu, that is psi is equal to psi naught e to the power of minus I 2 pi nu t. This will make it equation number 2. Now we will differentiating equation number 2 with respect to t. Differentiating equation 2 with respect to t, we get, that is psi is dou psi by dou t, psi naught is as it is, e to the power of x differentiation, we know that e to the power of x differentiation is e to the power of x plus differentiation of x, that is minus I 2 pi nu t into minus I 2 pi nu. This is the differentiation of the function we can write. So dou psi by dou t, which is equal to minus I 2 pi nu psi naught e to the power of minus I 2 pi nu t. So this psi naught e to the power of minus I 2 pi nu t can be replaced with this one, that is psi. So we will replace, that is dou psi by dou t, which is equal to minus I 2 pi nu psi by equation 2. We can replace like an psi with the psi naught e to the power of minus I 2 pi nu t. So nu, so from the Planck's energy relation we are having E equals to h nu. So nu equals to E upon h. So nu is the frequency, can be replaced with E upon h. So we will replace here, that is dou psi by dou t, which is equal to minus I 2 pi E upon h psi. So as already we studied about h cross equals to h upon 2 pi. So h upon 2 pi can be replaced with the h cross. So minus I E by h cross psi, because h cross equals to h by 2 pi. So this h by 2 pi can be replaced with h cross, that is dou psi by dou t. Now one more point here, we are having a minus sign here. So if you want to remove the minus sign, we have to multiply denominator and numerator by I. So from that we can remove the numerator minus I sign here. So I am doing I square E by h cross psi. So here numerator and denominator is multiplying with the I. So no problem with the equation. So I square value is minus 1. So minus 1 minus into minus plus E upon I h cross psi, here dou psi by dou t. Now I am sending this I h cross to the left hand side, so it will become I h cross dou psi by dou t is equal to E psi. So now we got the value of E psi. This E psi value will substitute in the time independent wave equation, as we are taking the Schrodinger time independent wave equation to solve the Schrodinger time dependent wave equation. So we will consider the Schrodinger time independent wave equation. We will substitute this value of E psi in the Schrodinger time independent wave equation. Substituting above equation in Schrodinger time independent wave equation. So that is E psi value we are going to substitute in the Schrodinger time independent wave equation. That is already we got the Schrodinger time independent wave equation, that is del square psi plus 2m h cross square E minus v psi, which is equal to 0. So here we are going to replace the E psi value, that is here we can write del square psi plus 2m h cross square E psi minus v psi, which is equal to 0. So E psi value we got I h cross dou psi by dou t, we will substitute here del square psi plus 2m h cross square minus I h cross, not minus, I h cross dou psi by dou t minus v psi, which is equal to 0. So we will send it to the right side. So it will become del square psi equals to minus 2m h cross square I h cross dou psi by dou t minus v psi. Like that we can substitute the right side. So now we will take this h cross square 2m here. So h cross square by 2m del square psi, which is equals to I h cross dou psi by dou t minus v psi. So v is the potential here and h cross is the reduced term of the Planck's constant and psi is a wave function. So we will take this v psi is here. So minus h cross square by 2m del square psi plus v psi, which is equal to I h cross dou psi by dou t. So now we will take the common psi from here. So we will h cross square by 2m del square plus v psi is equal to I h cross dou psi by dou t. I h cross dou psi by dou t, we can take the common as a psi. So as we know that this is a classical mechanics, from that it is given that Hamiltonian operator, that this can be replaced with the h cap. That is, an operator will be denoted in quantum mechanics with the cap. So we can replace this thing with the h cap. So whenever we are writing a cap in quantum mechanics, it means that it is an operator. So like that. So this I h cross dou psi by dou t we have seen in the previous only, which is given by E psi, which is the most important wave equation. So this is the Schrodinger time dependent wave equation. So here we are having the term that is t dou psi by dou t, that is a time dependent wave equation. So in the equation we are getting the t, that's why it is an time dependent wave equation. So this is all about the Schrodinger time dependent and time independent wave equation for this.